All right, so here we're trying to find our concavity on page 4. So my first step is simply to find where the second derivative equals 0 or does not exist. So I'm going to take my derivative. So f prime of x is going to look like 3 times 3, which will give us a negative 9/2 x squared. The negative 11 is a standalone constant, so that goes to 0. Then we have negative 3 times 2, so negative 6x over 2. And then the x to the first is a linear term, so that goes to 4. Now, before going further, I would simplify this. I would say it's negative 9/2 x squared minus 3x plus 4. That is simply my first derivative. Remember, for concavity, I am interested in the second derivative. So I do not set this equal to 0. I keep going and I take the derivative again to get my second derivative. So to take my derivative again, I'm going to have f double prime of x equals negative 9 times 2, so negative 18 over 2x. And then the negative 3x goes to negative 3, the plus 4 goes to 0. So I have that my second derivative is negative 9x minus 3. Now, remember, with concavity, we are working solely with the second derivative. So once we get the second derivative, that's what we're going to set equal to 0. So undoing PEMDAS here, I'm going to add 3 to both sides and then divide by negative 9. So that gives us x is negative 1/3. You'll notice that just like we did with the first derivative test, we don't have to worry about the does not exist here because there is no denominator. So we're just setting the second derivative equal to 0. We don't have to worry about the d and e part of it. So then we are going to draw our derivative number line. Now, when we draw our derivative number line, we are plugging into the second derivative. So I'm going to look at my second derivative. I have my negative 1/3. I will say negative 1/3 is not a critical number necessarily. This is just the point where the second derivative equals 0. So we're not referring to it as a critical number. It's just where the second derivative equals 0. And just like we did with our previous process, we're going to plug into the derivative right before we set it equal to 0. So specifically now it's the second derivative that we're plugging into, but it's the one right before you set it or right as you were setting it equal to 0. So if I go back to where I set it equal to 0, I have f double prime of x is defined as negative 9x minus 3. And now I will test a number into each of these intervals. So one number between negative infinity and negative 1/3, and then another number to the right of negative 1/3. So for the first interval, maybe I plug in negative 2. That gives us negative 9 times negative 2 minus 3. That's going to give us a positive 18 minus 3. So that gives us a positive. Now, what you want to be very, very careful about is this positive, because I am dealing with the second derivative, that positive does not tell us we're going up the hill. Because it's a positive second derivative, that tells us that it's concave up on the interval. So again, our number line is giving us completely new information. It's giving us information about concavity. So I like to write just a little CU there to say, okay, it's concave up on that interval. And then we'll do the same thing for to the right of negative 1/3. We might plug in 0. And that gives us 0 minus 3, or simply 0, or simply negative. So that negative again tells us different information. Because it's the second derivative, this negative is now telling us that the function is concave down on that interval. And it's all because we're looking at the second derivative rather than the first derivative. All right, so the final answers here in terms of what you need to type in on the homework is you would just say it's concave up on negative infinity to negative 1/3, and then concave down on the negative 1/3 to infinity.